hate to interrupt the wonderful music that's going on here, but let's get us started here. I'm Louis Normandan, COO of Wild Capture, and I'm here today for the XR enablement track, and we are having a blast. This next presentation is going to be outstanding by Markus Meixner, who is the CEO of Viewar. And I was speaking with Markus a little bit earlier, and Markus is somebody who believes that that spatial awareness is the next evolution of AR. He's been in the game for over a decade, and what they are doing right now with their demonstrations are amazing. So without any further ado, Markus Meixner, CEO of Viewar. Thank you.
Hi everyone. It's an honor to be here. Great to see that there's so much interest in this topic, and in this speech I will give you an overview of the capabilities of spatial AR, how to set up applications, talk about use cases, talk about how to generate ROI with that, and and make you aware of the possibilities that we have nowadays. If we look at the evolution of AR and especially tracking systems, it started with the very, very early times of using the compass and the camera image to do AR. Then it went to markers, as in tracking print on paper and so on, followed by object tracking, so using CAD models to enrich physical objects in the camera image. And then markerless AR came up as in identifying planes and putting things on the ground in front of you. And now we've reached the level of spatial AR, which is the ability of anchoring a persistent coordinate system. And with this ability, we have a huge variety of opportunities. So we can anchor items in the environment, we can do things like the indoor navigation, and lots of others. In terms of how to achieve spatial AR, you basically need to find out where your phone is, where your device is, and that can be done with a few technologies. First evolutions were using beacons, mainly known from 2D blue dot navigation with a very low accuracy, also hardware costs involved, and a very high setup time of recording fingerprints everywhere on your venue and on your location. Ceiling antennas are an alternative to that. They're even more expensive, and they even take more setup time, and still providing a very low accuracy actually. Markers, as in a very, let's say, rudimentary way of positioning, are also not a very practical way to go for. And now we have visual recognition and visual positioning, as in systems like SLAM and so on, that recognize where you are, that have a very minimum setup time and a high precision, and basically almost no hardware cost. To give you a bit of an overview of what you can do with spatial AR, I want to go through a few scenarios of what you can accomplish by showing a video. So the scenario starts with a technician receiving an emergency ticket through his task management system. He then opens a deep link that actually triggers a navigation to the point of interest of where to perform the task. So he's guided to the actual room. And as a brief overview of this capability, so it provides an efficient routing, and that can be used for product changeovers in facilities, in manufacturing facilities, and retailing locations, and you can also augment your environment with contextual information like security hazards, and basically improve efficiency and productivity. Once a worker has reached the actual room, he will be seeing a workflow. Some people refer to it as kind of a micro navigation. So augmenting the camera image with indications of where to perform a task, including instructions, be it textual, be it images, and also containing form elements. So you could ask the technician, please input the pressure that you see on this indicator, and he will go through this questionnaire and basically fill out the forms and perform the workflow. So this is a technique to archive knowledge. If you're in a shopping center or other facility or industrial scenarios, you want to let maintenance procedures and emergency procedures being performed by people who might not be familiar with the site. Currently, maybe one technician knows everything about this shopping center, but once he's not on site, things kind of get stuck. So this is a good way of digitalizing knowledge and improving workforces. And also this outlines that you can do a multi-dimensional decision tree. I will later on go into this a bit deeper, but basically you can ask questions, and if the user answers that the pressure is below 90 psi, he will see a different next step than if it's above 90 psi, for example. So as a brief summary of the workflows, it shortens changeover time with those step-by-step instructions. It minimizes error rates during scheduled inspections. It provides efficient guidance through any troubleshooting procedures and transfers knowledge from experts to new workers. And of course, it can be utilized for training and onboarding as well. The next feature I want to show is remote assistance. As you probably all know, remote assistance is the capability of transferring a live camera image and doing annotations in this live camera image. This is kind of a standard since years and is well known and heavily used by hundreds and thousands of companies already to provide quicker problem solving. But now you can use spatial awareness in combination with remote assistance. So instead of telling somebody, go to the left, let me circle in what you need to press next, you can just select from a menu that he has to go to the oil level indicator, and it will show him basically a navigation to this spot. So guiding him around the machine and again increasing the efficiency of this procedure. So this is a completely new dimension of remote assistance. You can have scenarios like 4I principle, guiding people through procedures with another person, guiding him remotely and not having to indicate everything manually. This also saves bandwidth, by the way, so you obviously need a lot less bandwidth if you just trigger navigations and point highlights, and you can basically speed up communication enormously with such an approach. So remote assistance allows you to shorten troubleshooting time with over-the-shoulder guidance and accessing special knowledge and experience during training or time-critical situations, and basically avoiding that experts don't need to be physically present or don't need to travel. How does this work? Basically, visual positioning and the technologies that we use in our system rely on 3D scans and panorama images. So what you do in order to set up a venue is you can use a stationary scanner, brands like Matterport, Leica, or Navis, and you set it up every few steps and create a digital twin with that. You can meanwhile even use Apple LiDAR devices, as in iPhone Pro and iPad Pro, to create a digital twin of your environment. Once you have this digital twin, this is the authoring interface, you can step in there virtually, walk through, and basically do the annotations and anchor the points of interest in your environment. Those can then be action points, as you could say, and can be utilized for various application types. So you basically choose a position and anchor a point. You can even anchor a so-called, we call it foreign ID. So basically, if this item has an SAP ID, then you can input this ID and generate a link with the navigation to this position. So a very quick way of an integration. If you want to create a workflow, you start by creating a workflow, assigning one or multiple 3D scans to it, and then you define those workflow steps. Each workflow step can contain textual information, can contain images, videos, but most importantly, it can have those 3D labels, as in highlighting the points of interest that you have been setting before. So this can be used to digitalize a process with multiple decisions and questions, as you see here, as in defining a next step if it's below 120 psi or if it's above 120 psi. So there are endless possibilities here. Also, these workflows, by the way, can be imported dynamically, and basically you can pass on JSON structure to trigger workflows in a very efficient way. How this basically looks like, you've seen the video clips. Here is now our version with the Magic Leap, which we're proud to be demoing even on our booth. And yeah, the worker is guided and sees all the augmentation and all the information enriched in the environment. So we see this as a next evolution of AR and providing fantastic capabilities for a variety of use cases. In terms of areas of use, so you can use this for industrial applications and manufacturing, scenarios like retooling for product changeovers. We have clients reporting saving of 60% of search time for walls and pipes. They have plants with like 9,000 walls and pipes on that location and 50 people taking care of manipulating those walls and pipes for maintenance processes. And so there are huge savings behind using AR for navigation, and you can use it for machine maintenance and repairs. You can use it for workforce onboarding and training. Public transportation is of course also an important topic, as in infrastructure maintenance, like repairing security cameras, changing electric equipment. You have hundreds and thousands of sensors. If you have IoT data spread all over a location, you can directly navigate to an IoT sensor failure and so on. Defect marking is also a very interesting thing, as in walking through an environment, tagging something with your phone and creating a ticket that also contains a coordinate of where this occurrence is and where somebody else should go. So there is nothing like going somewhere and reporting, I didn't find the cracked tile, I had to drive back. And yeah, commercial and residential, of course, wayfinding for visitors and location-based content, information, advertising, and also visitor behavior tracking. For hospital and healthcare, again, orientation and wayfinding, and infrastructure maintenance and repairs. Public areas and events are, of course, also requiring various application types that can utilize spatial awareness. As in the conclusion, spatial awareness is a groundbreaking technology that merges virtual and the physical world. Personally, I see it as the user interface we've all been waiting for. I think the last user interface revolution was the touchscreen, as in interacting with exactly what you want to press with your finger and instantly triggering that action. AR is your user interface to the actual world. You can see IoT data off a machine in your camera image. You can tap that machine and retrieve exactly the PDFs of that machine by walking through an environment. And so this link to the actual world has a lot of potential and can offer enhanced experiences, improved visualization and situational understanding, and empowers workers to perform tasks they haven't done before and kind of stepping in for a colleague. And so a brief summary about Viewar and our products. We have two products on the market, as an indoor with indoor navigation and service AR with indoor navigation, remote assistance and workflows. What differentiates us compared to other providers is that on the one hand we have a turnkey solution that you can use out of the box, but on the other hand we also have an SDK and source code access. So due to our system architecture of the C++ core and the HTML layer for the user interface, we can give you access to the source code of the user interface, and web developers on your side can then customize the applications to your needs. And this is a very important topic, and it might be a bit of a challenging phrase, but we think that it shouldn't be AR developers working on AR applications, because it should be the guys who come from web development, who come from dashboards, who kind of currently work with the business and the data that they need for solving their challenges. And the AR developers are focusing on the core topics. But we're abstracting those core topics, so you wouldn't need to worry about server infrastructure, about pathfinding, about 3D model converting, scan importing, and all those challenges are taken care of already. So you can, on day one, use your application right away, and on day two, you can start with integrations and customizations and adaptions. Yeah, that's it for now, and you can visit us at booth 225, right next to Lenovo and Meta. Feel free to contact me via email, LinkedIn, and also this QR code will lead you to a download of the presentation. Yeah, now it's time for some questions.
All right, we're going to take some questions. If anybody has any questions, you can go ahead and raise your hand. Meanwhile, I got one for you. So who out there is using these 3D scans, and how long does it take for an average turnaround?
So we have lots of client types, as in manufacturing. Pharmaceutical is a high focus area for us. They have a lot of quality assurance, and facility management is a good topic, as in equipping those workers. A setup usually involves a scan of a location. You can scan like 10,000 square feet within an hour, and then the scan would run through cloud processing, probably a few hours, and then it runs like 15 minutes through our system, and after that you can right away use it. This evening we will do a scan of the exhibition hall, and tomorrow morning you will be able to experience indoor navigation. With the LiDAR phone and tablet, I'm able to do a demo within 5 minutes. I can digitalize multiple rooms and capture them and create navigation points of interest.
All right, anyone else got any questions? Yes.
Thank you very much. It's a very exciting technology. So you were doing one scan for one of the facility room. How does it perform with the construction site? Because this keeps kind of like processing, kind of progressing throughout the days. If I'm scanning the day 1, does it work on the day 10, for example? Is there a discrepancy or a level of confidence the model will still work?
So you're bringing up, let's say, a somehow challenging situation that we can still address. As in, we say, if there is change of like 30% in an environment, we can still survive that and basically still localize within that environment. What you also need to be aware of that, for example, maybe the area at the elevators wouldn't change that much. So you can start tracking next to the elevators, and you can still navigate to those points of interest that you've set before, even if the environment changed meanwhile on the way while you move. Also, I want to point out that you can align multiple scans with our system, as in different floor levels, different area sections, to kind of combine larger areas. And also you can kind of overlap version from January with version from February, and then you can copy the points of interest between those scans. So this will also eliminate quite a lot of work. Also, you can partially update those scans. So if you look at Matterport and Navis and so on, you will have the ability out of the box to partially update scans.
Question here?
Is there any support or plans to develop multi-user scenarios where you're tracking 2 devices, you're able to tell where they are in the map in relation to each other?
So we have an out-of-the-box feature reporting the live position of users, so you can enable that, and it will send the live position of a user to an API, and that you can define, and that you can either save the data for analytics or trigger some actions. Maybe you want to inform somebody else if two people are in a dangerous zone area, for example, or if somebody goes into an area where somebody else is maintaining a large machine, for example, on a different floor level, and things like that are doable already. Yeah?
Okay. Do I understand correctly that currently you are using 2D videos or 2D pictures to create a scan, and then but in future, if it's time of flight sensor or lidar sensor, that can simplify your work?
So what we use is a combination of a 3D scan, so a point cloud or actually a 3D mesh, in combination with panorama images. So basically the visual recognition mainly relies on the panorama images for the positioning and uses the 3D scan for the depth to kind of retrieve a depth position of a 3D position of a 2D feature in the image. So it's a combination of both.
How are you creating 3D scans using your custom hardware?
We're building on top of market standards, and I mentioned the brands of Matterport, Nevis, Leica, Faro, and yeah, such well-known scanners. And especially Matterport, for example, is extremely easy to use. You can have service providers coming to your facility within a day doing such a capture. It's as simple as calling an Uber.
All right, everybody, a warm round of applause for Markus.